Welcome to the DIY Honda Garage channel. This presentation discusses the Diagnostic Trouble Code DTC P0172, which indicates that the rear bank of a Honda Accord from the years 2008 to 2012 is experiencing a fuel system issue where it is running too rich. This condition means that the engine is receiving an excessively high fuel-to-air ratio, which can lead to poor engine performance, increased emissions, and potential engine damage over time. The fuel system consists of various components, including fuel injectors, the mass airflow (MAF) sensor, and the air-fuel ratio (AF) sensor. Each plays a critical role in regulating the amount of fuel and air that enters the cylinders for combustion. Understanding the implications of this code and how to properly troubleshoot and resolve it is essential for maintaining vehicle performance and efficiency. The DTC P0172 indicates a problem with the rear bank fuel system being too rich. This means that the engine is receiving an excess amount of fuel relative to the air entering the combustion chamber. The primary components impacted by this issue include the fuel injectors, which are responsible for delivering fuel into the engine, the mass airflow (MAF) sensor, which measures the amount of air entering the engine, and the air-fuel ratio (AF) sensor, which helps to monitor and adjust the fuel mixture for optimal combustion. The MAF sensor is typically located in the air intake duct between the air filter and the throttle body. If it malfunctions or is contaminated, it can provide inaccurate readings, leading to a rich fuel condition. If not addressed, prolonged operation under these conditions can cause severe engine problems, such as spark plug fouling, catalytic converter damage, and higher hydrocarbon emissions. Several primary causes may lead to DTC P0172. A contaminated mass airflow (MAF) sensor can provide inaccurate readings, mistakenly indicating that more fuel is needed than necessary, thus causing a rich condition. When debris is present, such as lint or bugs, it obstructs the sensor's ability to accurately measure airflow. Additionally, incorrect fuel pressure due to a faulty fuel pump or fuel pressure regulator can introduce excess fuel into the system, causing an imbalance in the air-fuel mixture. Lastly, faulty fuel injectors can deliver too much fuel into the engine, especially if they are clogged or leaking. Identifying and rectifying these potential issues is critical for resolving the error code. The symptoms presented by DTC P0172 can significantly affect vehicle operation. Poor engine performance is common as the engine struggles to run efficiently with an improper fuel mixture. Increased emissions also result from an incomplete combustion process, which can lead to the vehicle failing emissions tests. Drivers may experience a rough idle, where the engine fluctuates in RPMs instead of maintaining a steady idle speed. Additionally, fuel consumption may rise as the engine uses more fuel to compensate for the imbalance, leading to decreased fuel efficiency. Recognizing these symptoms early can help prevent further damage and allow for timely repairs. The first step in troubleshooting DTC P0172 involves confirming the failure while the engine is idling. Start the engine and allow it to idle without any load. For vehicles with automatic transmissions, place them in park or neutral. For manual transmissions, place it in neutral. Using a Honda Diagnostic System, HDS, monitor the short-term fuel trim, ST fuel trim for both banks B1 and B2. Ideally, these readings should be close to 0 during idle. If either value reads 0.85 or less, it indicates that the fuel trim is too low, which suggests a potential problem recalling a rich condition. If the readings are acceptable, proceed to Step 2. In this step, you will confirm failure via the onboard diagnostic OBD snapshot. Review the snapshot and record critical parameters such as engine speed, vehicle speed, VSS, relative throttle position, TP, sensor, and accelerator pedal position sensor, APP. This data is essential to establish how the system was performing at its lowest fuel trim value. After capturing this data, operate the vehicle under the same conditions and look again at ST fuel trim for both banks B1 and B2. If these values drop to 0.85 or below under these conditions, it confirms the presence of a fuel trim issue. If not, the system may be operating normally. For the third troubleshooting step, focus on the MAF sensor for any debris. To do this, carefully remove the MAF sensor from the air intake duct. Inspect the sensor for lint, bugs, or other foreign objects that could be obstructing airflow. Debris in the MAF sensor can lead to incorrect readings, which in turn can cause the engine to run rich. If you identify contaminants inside the sensor, thoroughly clean the sensor and the surrounding area to ensure there is no more debris. Once cleaned, reinstall the sensor and proceed to the next troubleshooting step if necessary. The fourth step involves checking the fuel pressure to confirm whether it falls within the necessary specifications. Use a fuel pressure gauge and check the fuel pressure when the short-term fuel trim, ST fuel trim, for either bank B1 or B2 is at or below 0.85. For the 2008 to 2011 Honda Accord V6 models, the acceptable fuel pressure is between 57 to 64 psi. If the fuel pressure is within this range, proceed to the next step. However, if the pressure is low or high, a faulty fuel pump or pressure regulator may need to be replaced to correct the fuel supply issues. In this step, you will be checking the MAF sensor reading while holding the engine speed at 3000 RPM until the radiator fan activates. Ensure that specific conditions are met, such as the engine coolant temperature, ECT, sensor reading above 158 degrees Fahrenheit, 70 degrees, and all electrical loads in the vehicle turned off. While maintaining engine speed, monitor the MAF sensor readings through the HDS data list. The acceptable range for the MAF sensor on the 2008 to 2011 Honda Accord V6 should be between 9.1 to 12.9 grams per second. If the readings fall within this range, the MAF sensor is functioning correctly. Otherwise, further inspection or replacement of the sensor may be needed. In this step, you will assess the engine oil's condition. Start the engine and let it idle. Then monitor the ST fuel trim values for either bank B1 or B2 with the HDS. Next, gently pinch the hose between the positive crankcase ventilation, PCV, valve in the intake manifold. If you observe an increase in fuel trim above 0.80 when pinching the hose, it indicates potential contamination in the engine oil, which may require replacement of both the engine oil and oil filter. If there is no significant change, you can proceed to the next troubleshooting step to continue your investigation. In this step, it's time to address potential issues with the fuel injectors. Replace the existing fuel injectors with known good ones to see if they are causing the high short-term fuel trim, ST fuel trim readings. After installing the new injectors, operate the vehicle under the conditions that previously resulted in ST fuel trim B1 or B2 being 0.85 or less. Check the ST fuel trim values again. If the values are still 0.85 or less, it indicates that the fuel injectors were not the source of the problem. Otherwise, if the values improve, you have identified the faulty components. If fuel injectors are confirmed to be functioning normally, the next step is to evaluate the air fuel sensor. Replace the air fuel sensor with a known good unit. After the replacement, Again, operate the vehicle under the conditions that previously led to low ST fuel trim values. Monitor ST fuel trim B1 and B2 once more. If values remain at or below 0.85, this suggests that the air-fuel sensor is not at fault. If the fuel trim is corrected post-replacement, the air-fuel sensor was indeed causing an incorrect reading, contributing to the rich fuel condition. If previous steps did not rectify the fuel trim issue, the next troubleshooting step is related to the fuel itself. There's a possibility of an increased likelihood of fuel contamination if the misfire occurred shortly after refueling. To resolve this, remove the fuel tank unit, drain the existing fuel, and refill with known good fuel. After replacing the fuel, operate the vehicle under the same conditions where ST fuel trim B1 or B2 was recorded as 0.85 or less. Should ST fuel trim values continue to show low values, then the issue isn't with the fuel, and you should consider substituting the Engine Control Module, ECM, or Powertrain Control Module, PCM, next. The final step in troubleshooting DTC P0172 involves confirming the repair has been successfully completed. Start by turning the ignition switch to the on position. Reset the Engine Control Module, ECM, or Powertrain Control Module, PCM, using the HDS. Perform the required idle learn procedure, which helps the module recalibrate to the new settings. Next, start the engine again, holding the speed at 3000 RPM without any load until the radiator fan comes on, and let it idle afterward. Finally, check the ST fuel trim B1 and B2 values once more under the same conditions. If the readings still maintain low values, further investigation into underlying fuel system issues is warranted. However, if the repair is confirmed successful, the system is normal and operating properly. The final repair verification ensures that all procedures have been executed correctly and thoroughly. Reset any fault codes present in the system using the appropriate diagnostic tool. Take the vehicle for a test drive to ensure it operates smoothly without any persistent issues. During the drive, observe the ST fuel trim values again during varied engine conditions to confirm if issues are resolved. If the values return to acceptable levels with no faults pending, it indicates a successful repair. Monitoring vehicle performance over a few days following the repair can also help catch any recurring issues early on. Preventive maintenance is crucial in avoiding DTC P0172 and ensuring the longevity of your vehicle's engine performance. Regular inspections of the mass airflow (MAF) sensor can help identify potential contaminants before they cause significant issues. Likewise, checking and using high-quality fuel will minimize the risk of fuel contamination, which is a common culprit for rich conditions leading to error codes. Furthermore, replacing air and fuel filters periodically can ensure that the engine receives adequate airflow and clean fuel, which is essential for optimal combustion. By being proactive with maintenance, potential issues can be addressed before they escalate. In conclusion, understanding DTC P0172 is essential for maintaining your Honda Accord's performance. This code signifies that the rear bank fuel system is running too rich, which can be caused by issues such as a contaminated mass airflow sensor, faulty fuel injectors, or improper fuel pressure. By systematically troubleshooting the problem using the outlined steps, you can accurately diagnose and correct the underlying issues. Following repair, implementing preventive maintenance practices ensures that your vehicle stays in optimal condition, ultimately extending its service life. Remember that regular checks will help catch potential problems early and save on costly repairs down the road. Please like and subscribe to the channel. See you next time.